to sum up this chapter, relations and functions, what all did we do in this particular chapter? See, we started off with a very simple concept of what is a relation and different types of relation, correct? And once we know that there are different types, so correct, you have reflexive, you have symmetric, and you have transitive. Now, what do you mean by reflexive? If you have some element A and A comma A belongs to that relation set, then we say it is reflexive. And when we say it's supposed to be symmetric. Symmetric meaning what? If you have A comma B, then B comma A should also belong to R, right? And when we say transitive, if you have A comma B and B comma C, then A comma C, if that belongs to the set R, then the relation is transitive. If the relation is all the three, reflexive, symmetric, and transitive, then we call that as an equivalence relation, isn't it? Now that we know what is an equivalence relation and all, as we moved further from relation, then we moved on to functions. Now in functions, again, very important, function is always between two sets, isn't it? One domain set and one range set. And the function relates these two sets. So from A to B, some function will be defined. Now a function is defined. So a function or a particular function what you have can be of two types, including one more three. That is, the first one is one-to-one or what we call as injective. Now whenever we say one-to-one, one element of domain has only one element in the range. That is, there is only one single relationship, correct? So one element of domain has only one image, a unique image. That's what we call as one-to-one. Now when we say onto meaning what? Every element in the range, it should have at least one element in the domain or what we call as the pre-image, isn't it? Now this is basically onto. Now when we talk about the next one, that is the bijective. So injective is one-to-one, surjective is onto. If a function is both injective and surjective, then we call such functions as bijective functions. Now to add on to this particular point itself, every bijective function is an invertible function. That means inverse exists for all bijective functions. The other way around also. If a function has an inverse, then it is a bijective function. So both the ways it is true, right? Then we moved on to the next part, that is the composite function. So composite function, it relates multiple sets. Like if you have three sets A, B, C, and we have a function f and we have a function g, then we have g of f of x, which relates from one set to another set. Likewise, we also have FOG, f of g of x. So these are basically composite functions. Now we already discussed about inverse. All inverse functions, they are bijective, and once you have to find the inverse, and you do the math according to how the question will be. Right? So this is basically the chapter relations and functions.